Hello students, myself Dr. Niranjan RS, Assistant Professor, Department of Physics, Government First Grade College for Women, Polanersipra. Today I am going to discuss the topic vertical oscillations of a loaded light spiral spring under the unit conservation of energy. First I will discuss simple harmonic motion. Simple harmonic motion refers an oscillatory motion where the restoring force is directly proportional to the displacement from the equilibrium position. In simple harmonic motion, force is always in the direction opposite to the displacement. Restoring force is directly proportional to the displacement. The meaning is, if the displacement is more, the restoring force exists in a simple harmonic motion is also more. The example for this simple harmonic motion is a pendulum, a bob attached to the spring. Conditions for the simple harmonic motion: a fixed point at which the mass is in equilibrium, a restoring force which returns the mass to its equilibrium position if it is displaced from the equilibrium position. Now we look into the vertical oscillations of a loaded light spiral spring. Consider a massless flat spiral spring whose one end is fixed to the rigid support and the other end is suspended by a mass m, which is shown in figure. If the spring is stretched by the downward force at the lower end, then released, the restoring force acts on the spring and it tries to bring it back to its original position. The restoring force exists in the spring, bring back this mass to its equilibrium position. Then mass starts to oscillate back and forth by the force due to the extension and compression of spring. If we say x is the displacement from its equilibrium position, then dx square by dt square is the acceleration and the restoring force is given by F is equal to m into dx square by dt square, where it is equal to minus k into x. If the negative sign indicates that the force is directed upwards, where k is called a spring constant. Further rearrange this equation, what we get, taking m to the denominator and minus k to the left hand side, we get a second order differential equation, that is dx square by dt square plus k by m x equals 0. If we compare this second order differential equation, then what we get, in the place of omega square we get k by m. Then taking square root on both sides, we get omega is equal to root of k by m. vertical oscillations of the loaded light spiral spring and time period is given by t equals 2 pi by omega. Substitute that omega, what we get? 2 pi root of m by k. If S is the mass of the spring, then T is written as 2 pi root of m plus S by 3 over k. If a small mass m produces an extension y in the spring, then k equals spring constant equals mg by y. Substitute the value of k mg by y in the above equation. What we will get? T equals 2 pi root of m plus S by 3 y by mg. Then what is the definition of period? The time in seconds it takes for a vibrating object to repeat its motion. Seconds per vibration, or we can say that it is the time taken to complete the one oscillation or one cycle. This content is taken from these 4 books. These are the references for this topic. Thank you.